Right, guys, we've looked at a bit of theory. We looked at linear inequalities, very important principle. When you divide by a negative, you change the inequality sign around. But now let's look at quadratic. Quadratic is the x squared does not want to go away. If you have a look at the slide, we've got x squared is less than or equal to 9. Now, that's a little bit of a problem there. That's quite a problem. Now, how do we do this? Let's go to some paper here. We've got here x squared is less or equal to 9, and we want to solve for x. Now, the problem here is that this, if you look at the inequality, is the x squared won't go. It would be very different if you looked at a sheet of paper. If I had something like this, if I had 2x is less than 9, well, that's okay because you simply just divide. And you can do it if it's an x thing, or even if it was negative 2x. Let's go and have a look at that. If I bring it down, what if we were dealing with negative 2x here is less or equal to 9? Well, that would be x is greater or equal to negative 9 over 2. No problem with these. There's no x squared. But if you look at this one here, x squared is less than 9. We're not going to want to just square root both sides. We remember that we don't do that. What we've got to do is follow the procedure. Now, how does it work? Let's have a look. Here's x squared. Less or equal to 9. What we do is we bring that, we say therefore, bring that across. Okay. And very important, factorize as a difference of two squares. Look at that. Beautiful maths there. Okay, so always bring across and factorize. I can remember if you take minus 9 or 9 across, you're not changing the inequality. It's only by dividing or multiplying. Now, what we can do is we draw a number line and we draw a parabola here. Very, very cool. So here I'm going to draw a number line, and my parabola is very, very happy. X squared is happy. So let's bring him in. And what we do is we say, well, what would make these naught? What are where does it cut? The parabola cuts. Well, you could have factorized, but really what we're talking about is where x plus 3 is equal to naught. So x could cut at negative 3. That's where it cuts the x-axis, or where that bracket equals naught, like we would do with normally getting the x-intercepts. So we've got that. Now, what do we know? Okay, it's definitely going to be including. It's where it's cutting, so it's going to be closed over here. We're including those. Okay, so, and the question is, this means below, or cuts the x-axis, below the x-axis, or cuts the x-axis. Where would that be? Below is from there to there. So it's from minus 3 less or equal to x less. You always keep it in that form. The other way you could do is you could go like this. And that would also be acceptable, or that. You can do that, that's fine. One of those methods are quite important there. But you must, and don't go the other way. It's if you put the x there, all these x's here, the parabola is below, from minus x is less than the x is less than 3, including. Very, very important, that one. Okay, shall we look at another example quickly? Have a look at that one on the slide. Okay, what have we got? X squared is greater than x plus 6. Very important, x squared won't go away. Quadratic, let's write it down. Okay, so we've got x squared is greater than x plus 6. And what's the first important thing? Therefore, bring everybody across. Okay, and then do it. And remember, it's great. It's not cutting. This means above the x-axis. Okay, so therefore, let's factorize x minus 3. X plus 2 is positive, which is great. And let's get our little x-intercepts of our happy parabola. It's a positive x squared. Great, draw it in. Okay, what makes that naught? That's 3. What makes that naught? Negative 2. If you stuck, always put them, go x minus 3 is equal to naught, x is equal to 3, or x plus 2 is equal to naught, so x equals negative 2. Now remember, it's open, so we're not including those. We don't want them. It's just above the x-axis. Well, where's the parabola above? It's above there, and there. It's clearly above. Okay, so that's great. Now, what does that mean? Is to all the values of x to the right of 3. So x is greater than 3. Don't forget the word, and to the left of negative 2, it's above. So it's x is less than negative 2. And there's your solution. X is less than negative 2, or x is greater than 3. Very, very important with these kind of things. So remember, above is clearly going to be this way, where you go x to the right and x to the left, and clearly above. That's so important. And remember, guys, it's so important that you deal with this kind of thing. If you look at this, if you take another one, just making up some as we go along, you might have a situation where you've got something like 9 minus x squared. What if you had 9 minus x squared is going to be less than 0 or equal to. That's a bit of a problem, because what do? How do we approach that negative? It's a sad parabola. So we need to explore that. One way of possibly doing it is we could say 3 plus x, 3 minus x, but we're dealing with a sad, but we want to keep the parabolas happy. So my suggestion, and we're going to explore this in the next lesson, is I would then just put these together, make it, in other words, if you make it minus x squared plus 1, you're not changing, you're just swapping them around. You're doing that. Now when you get to this point, what I would suggest you do is multiply throughout by the negative and swap them around. Okay, swap it around. Very, very important. The x squared doesn't go. Make the coefficient of x squared positive. Now, what we're going to do is explore this, getting that negative x squared positive. In the next lesson, we're going to do this. So stay with me. I'm really enjoying being with you guys. Inequalities is a wonderful part of the syllabus. So, catch you soon.